Hello, this is Mr. Best. Welcome to the closure questions from Chapter 9, 120 to 131. Question 120. Write an equation that represents the graph at the right. So we want to identify what this boundary line is. Alright, so let's find the y-intercept. And that appears to be at 0, negative 2. And then if we go up, remember this is 2, up 2 and over 4, that would be a slope of 1/2. So it looks like our boundary line is y equals 1/2 x minus 2. And since the point 0, 0 is a solution, then when we plug 0 in, we want, and that would cancel. So how does 0 compare to negative 2? 0 is greater than, and we want that part of the solution to be true. So it looks like we'll have the inequality y is greater than, not equal to though, because it's a dotted line, 1/2 x minus 2. And so once again, when I test the point 0, 0, then what we'll get is a true statement. So 0 is greater than negative 2. That is true, and that's why we would shade above here. Question 121. Is the point 0, 4 a solution to the system of inequalities below? Justify your answer. So to see whether it's a solution, we will plug it into each of the inequalities and then identify whether it's true for both of them. So if we plug in y equals 4, is 4 less than or equal to negative 3 times 0 plus 4? Or is 4 less than or equal to 4? Yes, so that one's true. So let's go ahead and check the second one. Y is greater than x squared plus 3x minus 2. Once again, plug in 4 for y and 0 for x. And so it looks like we will get 4 is greater than negative 2, which is once again true. So is the point 0, 4 a solution? Yes, it is. So 0, 4 is a solution to this system. Question 122. Factor these expressions completely if possible. So in part A, we have x squared plus x minus 30. We're looking for factors of negative 30x squared that will add to give us 1x. That'll be 6x and negative 5x. So we're going to have an x times an x, and then we'll have a plus 6 and a minus 5. And as you guys are starting to do these, you'll start to notice some patterns here. We have the x plus 5 or the x plus 6. And the minus 5, which you'll also notice show up here and here. Think about when that occurs. It doesn't occur all the time, but when does that occur where maybe it'll make it a little bit easier to factor some of these. And so then we'll have x plus 6 times x minus 5. On part B, we have negative 3x cubed plus 23x squared minus 14x. So we want to make sure we are factoring completely. I notice there is a variable of x that is in common. I'm also going to factor out the negative in front of the negative 3x cubed, so that first term is positive. So that'll be negative x, and then we'll have 3x squared minus 23x plus 14. And then now we can do our generic rectangle. We have 3x squared and 14. And so we want to multiply to give us 42x squared, but add to give us negative 23x. So it'd be negative 6x and negative 7x. Sorry about that. I was thinking negative 13. Let's try that again. How about negative 21? And negative 2. That would multiply to give us 42 and add to give us negative 23x. So we'd have to put the 3 up here because that goes into 21, doesn't go into 2. So 3x and x. That means this would be a minus 2, and that would be a minus 7. So it looks like our final answer, make sure it's factored completely, would be negative x times 3x minus 2, and x minus 7. Alright, and on to C. 2x squared minus 5x plus 4. There is no common factor, so we're just going to go straight to the generic rectangle. We got 2x squared, positive 4. So what multiplies to give us 8x squared, but adds to give us negative 5x? So factors of 8, 1 and 8, and 2 and 4. And it doesn't appear either one of those is going to give us a negative 5x, so therefore this one is not factorable, or we could say it's prime. Alright, and then we will move on. I'll have to do D up here. So we have 6x cubed plus 10x squared minus 24x. So similar to B, where we have an x in common, but it appears on this one when we have more than just an x, it looks like we also have a factor of 2. So we'll factor the 2x out. That'll leave us with 2x times 3x squared plus 5x minus 12. And then we can use our generic rectangle on this. I'm going to move it over here on this one. So we're looking for factors of 3x squared, or we have 3x squared tiles, I guess, and then negative 12. So we're actually looking for factors of negative 36x squared that add to give us 5x. So 9 and 4 would be 9x and negative 4x adds to 5, multiplies to negative 36. And then the side lengths, this would have to be a 3x, and this would be an x, and then plus 3 here, and it looks like minus 4 there, which will also give us the negative 12. So our final factored form is 2x times 3x minus 4 times x plus 3. So B and D both had a greatest common factor in that you had to make sure you factored out if you were going to be able to factor completely. Question 123. Solve each inequality below for the given variable, then represent each solution on a number line. So part A, we have 4x minus 3 is equal to 9. We're going to set this up so we can find the boundary point. And the boundary point is 3. So on our number line, we have 3, and we want to decide is it an open or closed circle. It is a closed circle because it is equal to, so that means 3 is a solution, and then we are going to test a point, or test a value for x, which we're going to use 0, and we're going to plug that in. We get 0 minus 3 is greater than or equal to 9, so is negative 3 greater than or equal to 9? No, it's not, which means this is not a solution, so we want all values going to the right. So therefore, x is greater than or equal to 3. So we want the number line and the solution. Alright, on to B. So I'm going to distribute the 3. 3 times t is 3t. 3 times 4 is 12. Change it to equal so we can find the boundary point. Subtract 12. And we get negative 7. Divide by 3, and t is equal to negative 7 thirds. So 0, negative 7 thirds is over here. On this one, it is an open circle because negative 7 thirds is not included. It doesn't have an equal to sign in the inequality. And then we need to test a value. So let's test x equals 0, or t, I guess. That's the variable we're using. And that would be 0 plus 12 is, well, let me go back. Make sure I'm accurate here. Let's go back to the beginning. 3 times 0 plus 4 is less than 5, and that would be 3 times 4 is 12. So is 12 less than 5? No. So that is not a solution. So we only want the values going the other way, which means we want all t values that are less than negative 7 thirds. Alright, on to C. 2y divided by 7 is equal to 8. Multiply both sides by 7. So that's 2y equals 56. Divide by 2. And y is equal to 28. So at 28, we have an open circle. It's not included. There's no equal sign on the inequality. And we will test the point 0. And when we do that, we get 0 over 7 is less than 8. 0 divided by 7 is 0. 0 is less than 8 is true. And so it is true over here, which means that's this way we're going to have our arrow going. So we're going to be going all values to the left of negative 28. So our solution is y is less than 28. Don't forget to write that inequality at the end stating what the solutions are. And then on to D. We have 5x plus 4. Is equal to, I'm going to go ahead and distribute the negative 3, is equal to negative 3x plus 24. I'm going to add 3x to both sides. That would give me 8x plus 4 equals 24. Subtract the 4. Divide by 8. And that would be 16 is 2.5. Alright, so on the number line, we have 0 and 2.5. It will be a close, nope, it's an open circle again. There's no equal sign. And then we will test 0. And if we test 0, we will get 0 plus 4 is greater than negative 3 times 0 minus 8. And that'll be 4 is greater than negative 3 times negative 8. So is 4 greater than 24? No, it is not. So 0 is not part of your solution. So values to the right of 2.5. So we would want all x values greater than 2.5 as our solutions. So when you guys are doing these problems, just be aware that you are solving the inequality for the given variable, and you're representing your solution on a number line. So once again, we want a number line, and you can see that I boxed in the solutions as inequalities as well, so both parts. Question 124. Brian was holding a ballroom dance. He wanted to make sure girls would come. So he charged boys $5 to get in, but girls only $3. The 45 people who came paid a total of $175. How many girls came to the dance? Well, we need to write let statements so we know what variables we're using. We can, looks like we're looking for two different things. It does say we're only looking for the number of girls, but we also need to figure out the number of boys potentially as well. So let's let B equal the number of boys that attended, and then we can let G equal the number of girls that attended. Alright, how do we write an equation for this? Well, boys get charged $5 and girls get charged 45, girls get charged $3. So boys 5, girls 3. So 5 times B, the number of boys that are going, plus 3 times G, the number of girls going, should total $175. We have two variables though, so we also need another equation. Well, there's 45 people attending, so the boys plus the girls should equal 45. And so now we can solve this. It's a system of equations, two variables, two unknowns. We can solve using elimination, or we can solve using substitution. I'm going to go ahead and use elimination. I'm going to multiply this by -3, the second equation. And so my first equation stays 5b plus 3g equals 175. And then when I multiply negative through, I get negative 3b minus 3g equals negative 135. So when I add those up, I get 2b, the 3g's cancel, is equal to 40 divided by 2, and B is equal to 20. Now, we didn't need, it says how many girls came to the dance. So we can plug B back in and get 20 plus G is equal to 45, subtract the 20, and we get G is equal to 25. So we know that 25 girls came to the dance. So make sure you answer the question that is being asked. Question 125. Solve each quadratic equation using the specified method. So the first one on A, it wants us to use the quadratic formula. So A is 3, B is 4, C is negative 7. It does have to be set equal to 0, and it is, so we're good there. X is equal to the opposite of B, plus or minus the square root of B squared minus 4 times A times C divided by 2A. So that would be negative 4 plus or minus. Plug 4 squared minus 4 times 3 times negative 7 into your calculator and see what you get. And so we have the square root of 100 divided by 6. The square root of 100 is a perfect square. So we have negative 4 plus or minus 10 over 6. And then we can separate that into both of our different answers. Negative 4 minus 10 over 6 and negative 4 plus 10 over 6. So this would be negative 14 over 6, which would be negative 7/3. This would be 6 over 6, which is 1. So the answer for part A is our two values. Our x equals negative 7/3 and 1. So those are the two places the graph crosses the x-axis. Alright. On to B. B says factoring, so we have x squared minus 3x minus 18 equals 0. I'm just going to go ahead and factor this one, x minus 6. X plus 3 is equal to 0. And then we're going to use the zero product property and set our factors equal to 0 and get two solutions. X equals 6 and x equals negative 3. So that's factoring. Then on C, it wants us to complete the square. So x squared plus 4x plus 1 equals 0. So let's figure out how we need to complete the square. We know we have an x squared here. We have a 4x. We have to split that in half because we have to create that square, which gives us x plus 2 on each side. So we know what the side lengths of the square are. Now 2 times 2 is 4. So we need 4 tiles here to complete the square. We only have 1, so we have to add 3 to both sides. Now that gives us the total of 4 that we need. So that's good. That'll give us an x plus 2 squared. That's the side lengths, and then it's equal to 3. So now we can take the square root of both sides, and this will give us the absolute value of x plus 2 is equal to the square root of 3. And then remember, absolute value is distance from 0, so it could be negative square root of 3, or it could be positive square root of 3. So x equals, subtract the 2, negative 2 minus the square root of 3, and on the other one it would be negative 2 plus the square root of 3. So those are your exact answers, if that's what we're looking for. So if this is the exact answers we're looking for, we have negative 2 minus the square root of 3, and negative 2 plus the square root of 3. Let's also get the approximate answers as well. So plug those into your calculator, and let's see what we get for each of those. So negative 2 minus the square root of 3 is approximately negative, here let me fix my symbols here. Since it's approximate, I'm going to use the curly signs here. So this would be negative 3.73. And then if you take negative 2 plus the square root of 3, you get negative 0.27. So those are your approximations. Alright, part D, we're going to use a graph, so we're going to have to find some important information as we solve by graphing. And when we're solving by graphing, remember, we're looking for the x-intercepts. Where does the graph cross the x-axis? So when y is 0. So the first thing is, looking at this, maybe we try to factor it first to see if it is factorable. So let's find out. We have it at 2x squared and a negative 12. So we are looking at factors of negative 24x squared that are going to add to 5x. And let's see, 8x and negative 3x adds to 5x and multiplies negative 24x, so it does work. So we have 8x and negative 3x. And so our side links, this would be a 2x and an x. Have to be a plus 4 to get you 8x, and then a minus 3 to get negative 3x, and then 4 times negative 3 is negative 12. So it does factor to 2x minus 3 and x plus 4. And then you can use your zero product property to find the x-intercept. So this would be 1.5 and negative 4. So if we graph 1.5 and then negative 4, we also know the y-intercept is at negative 12, which would be down here somewhere, because when you plug 0 in for x, you get negative 12. And really at this point, we have already found the zeros. If you were using a graphing calculator, you would have to use the function on the calculator for the zeros to calculate what the zeros are. I'm going to go ahead and find the vertex just to kind of complete my graph here, though. This will be good practice anyways. To find the middle, because those numbers are not integers, we got a 1.5. We can add the 1.5 plus the negative 4 and take half of it, and that will give us where the middle of those two numbers are. And that's negative 1.25. So definitely hard to graph accurately, but that would be the middle. And so your vertex would be negative 1.25 comma something, and you would plug that in to all your x values and see what the y value is. So I'll write it down here, and then I'm just going to plug it into my calculator and see what I get. And so I got a y value of negative 15.125. So I can't even really plot that accurately because I only went by tens here, but it's going to be, if that's negative 12, it's going to be somewhere down here. And so graph's going to look something like that. But we do know our solutions. X equals negative 4 comma 1.5, where the graph crosses the x-axis. Question 126, given the quadratic function f of x equals x minus 1 quantity squared minus 4, state the location of the vertex. Well, this one's in graphing form or vertex form, so remember x minus, this represents your x coordinate. If you're looking at this, then it's the opposite of negative 1, so vertex would be at 1 comma, and then the part right here at the end is the y coordinate, which is negative 4. So we know the vertex is at 1 comma negative 4. The x-intercepts we can find by setting equal to 0. So on part B, we could say 0 is equal to x minus 1 squared minus 4. So we can add 4 to both sides. And we can, the square is already completed, so we don't have to do that. But we can now, since we're in that form, we can take the square root of both sides and get 2 equals the absolute value of x minus 1. And the absolute value is a distance, so it could equal negative 2, or it could equal a positive 2. So if we add 1, we get x equals negative 1, or x equals 3. So our x-intercepts are at negative 1, 0, and 3, 0. So let's plot the vertex 1, negative 4, and then negative 1, 0, and 3, 0. And that is in the middle, so that does make sense. Sketch the graph of the function. I'm going to find one more. I'm going to find the y-intercept. When we plug 0 in for x, we get 0 minus 1 squared minus 4. So that would be negative 1 squared minus 4. 1 minus 4 would be negative 3. So the y-intercept would be at negative 3. So here, and then I'll do the point symmetric to that over there. And so that will allow us to get a good sketch of the graph. Question 127. Graph the system of inequalities below. So we have one, the first one here. I'm going to do this one in blue. So y is equal to x squared. So that's your quadratic. And if you do a table, and since there's no other stuff to it, we can do a couple values of x, some positive, some negative, and then 0. And we're just squaring these. So you're going to see the symmetry pretty quickly, because if you square -2 or 2, you get 4. And we could go down to 3, because 3 squared is 9. So let's go ahead and graph that. -3 is at 9. If you square -2, you get 4. -1 is 1, 0. And then from there, you can graph. Now it is a dotted line, dotted curve here. Okay. Now we can't test the point 0, 0 on this one, so we're going to have to test something else. Let's test the point. We'll still use a 0, but we will go 0 and then up 1. Okay. And so this would be y is 1 is less than or equal to 0 squared. So is 1 less than or equal to 0? No. So we would not plot anything in there that or shade anything in there. So we will be shading on the outside, all of the outside of the parabola. Those are all your solutions. Okay. Now, we do have another one, so let's get to that. I'm going to go ahead and erase that just so you can kind of get a visual where it is, and then we'll go look at the other one. So now we have y is equal to x plus 2. Now this is a line, so we already have everything we need. We know the slope is 1 and the y-intercept is 2. So 2, and then a slope of 1. So you can get a couple points in there with that one. And then we can graph that line. Now it is a solid line because it is equal to. And we can test the point 0, 0 on this one. So if we test 0, 0, we get 0 is greater than or equal to 0 plus 2. Is 0 greater than or equal to 2? No, it is not. So we will not shade on that side because that's where 0, 0 is. We would be shading on this side. Okay? So think about where you shaded before and where you're shading now. Where is that intersection of the two? The other thing we could look at is the different regions we have. We have one region here, a region here, here, below, and then also don't forget that one, if you didn't see me write it, at the bottom here. That was number 5. So you could test all of those regions to see in terms of that. Let's go ahead and see if we can figure it out by the shading though. So with the red line, we said that the test point 0, 0 was not true. So we were looking at things in this direction. With the parabola, the point 0, 1 was not true. So we were looking at anything in this direction below. Okay. So where do you notice that they're in common? Well, maybe you see that it's this region right here where they're in common. Okay, and right over here in this little part, and now if we extend it, it'll be a little bit bigger, but that little section as well. So there's kind of those two regions right there where they do share it in common. Question 128. Lou says to his granddaughter, Audrey, even if you tripled your age and added 9, you still wouldn't be as old as I am. Lou is 60 years old. Write and solve an inequality to determine the possible ages Audrey could be. Okay, so let's set up our let statement. Let's say let A equal Audrey's age. Alright, Lou says to Audrey, even if you tripled your age, so let's triple her age and add 9. Okay, you still wouldn't be as old as I am. Lou is 60 years old. So that would be less than 60 years old. So let's go ahead and solve this and see what we get. So 3a, subtract the 9, that would be 51, and then divide by 3, and we get 17. So if we're thinking of our number line here, we got 0 and 17. 17 is not included. And if you test the point 0, you would get 0 plus 9 is less than 60. Is 9 less than 60? Yes. So we would want all these values over here. Now, think about this though. At 0, we're not going to be anything less than 0. So none of those are really going to be solutions. So how old could Audrey be? Audrey could be less than 17 years old. And so make sure you write the answer to the question. And once again, read the directions because it does say write and solve. So we did write the inequality. We did solve it on the graph, and I probably should even write the answer x is less than 17 as well. Question 129. The cost to rent a DVD has decreased 10% per year over the past several years. If the current cost is $5, write an exponential function describing this situation. Alright, so x represents our time, and time is in years. And then our y represents the cost of the DVD. So right now, y is equal to the initial cost of $5 times, now it decreased 10% per year. So we started 100%, we decreased 10%, so that puts us at 90% or 0.9, and then raised to the x power. So part A just wants us to write the exponential equation, which we did. And then part B, according to the equation, what did it cost to rent a DVD 5 years ago? So when we go to plug this in, this is talking about 5 years ago. So our time, we're going backwards 5 years. So x would actually represent a negative 5. So if we plug that in, that'll give us the cost 5 years ago. And we round to the nearest cent, and that'll be $8.47. So 5 years ago, a DVD cost approximately $8.47. Question 130. The hare leaps 500 centimeters every 20 seconds. The tortoise crawls 250 centimeters every 50 seconds, but gets a 1,000 centimeter head start. Use any method you know to determine how long it takes the hare to catch up to the tortoise. So there are lots of different ways that you could look at this problem. I'm going to look at it in terms of an equation where I'm going to let x equal the time traveled, and y will equal the total distance. And that will be measured in centimeters, and time will be measured in seconds. So the hare, if I'm looking at he's going to travel a total distance of y equals 500 centimeters every 20 seconds. So that's his rate of time. And so we could simplify that to be 25x. So he travels 25 centimeters every second. Whereas the tortoise travels a total distance, and his rate of change is 250 centimeters every 50 seconds. But he also gets a 1,000 centimeter head start. So his equation would be y equals 5x plus 1,000. So he's only traveling 5 centimeters every second, where the hare is traveling 25 centimeters every second. So if we want to figure out how long it takes for the hare to catch up to the tortoise, then we can set our two equations equal to each other by using our substitution method. 25x is equal to 5x plus 1,000, and this will give us when they meet, how long it takes for them to catch up, or the hare to catch up. So subtract 5x, this will give us 20x is equal to 1,000. And if we divide by 20, x is equal to 50. So that means it's going to take a total time of 50 seconds for the hare to catch up to the tortoise. So just to clarify what the question was, using a method to determine how long it takes the hare to catch up to the tortoise. So it doesn't ask for the distance or anything like that, it just asks for the time. So we were able to answer that by solving and getting 50 seconds. And as always, make sure you answer the question that is being asked. So the hare catches the tortoise after 50 seconds. Question 131. Find the equation of an exponential function of the form y equals a times b raised to the x that passes through the points 3, 13.5 and 5, 30.375. So we've solved these types of equations two different ways. We've set up systems and solved. We've also really just looked at a table and helped identify it this way as well. So we don't know what 0, 1, 2 is, but we know what 3 is. 3 is 13.5. We don't know 4, but we know 5 is 30.375. So we know that we have to multiply by this multiplier of b to get to the next term. So on this one, if we take 13.5 times b, or b squared, we should get a value of 30.375. So we can take this and solve this equation by dividing by 13.5. And we get b squared is equal to 2.25, and then we square root 2.25, and we get b is 1.5. So we know b is 1.5, but what we don't know is we don't know the initial. And a is the first term. So now we're going to have to work backwards by dividing by 1.5 to see what the term is. So if we take 13.5 and divide it by 1.5, we get 9. 9 divided by 1.5 is 6. And if we take 6 divided by 1.5, we get 4. So our initial value is 4, our multiplier is 1.5, so that gives us the information we need. Y is equal to 4 times 1.5 raised to the x power. Now, another way that you could have done this is, instead of using the table, set up an equation using the 2 points. So we could have used the equation y equals a times b raised to the x power, and then plugged in what we knew. 13.5 is equal to, we didn't know the a value, we didn't know the b value, and then x was 3. And then we would do a second equation, 30.375 is equal to a times b raised to the x of 5. So there's our system of equation. We could have, divided this by b cubed, and then a is equal to 13.5 divided by b cubed, substituted that into our second equation here for a, so that would be 13.5 divided by b cubed times b to the 5th, and so that would be 30.375 is equal to 5 minus 3 is 2. Since we're dividing common bases, we subtract the exponent, so that would be 13.5b to the second power. And then you'll notice that's really right back to where we were on the one above. Divide by 13.5, you get b squared is equal to 2.25. Take the square root and you get b as 1.5. Now on this one we didn't know the a value yet either, so now we'd have to plug that back in, probably to this part right here, and say 13.5 divided by 1.5 cubed. So if we plug that into our calculator, we should get 4 by what we did earlier, so let's check that. And we do get that value of 4. So knowing that, we could write y equals 4 times 1.5 raised to the x power. So you get the same thing, but just a different approach in terms of looking at it.